Hi, my name is Steve Morgan. I'm the Motion Control Product Manager for Gerrie Electric. Today I'm going to show you how to size up a belt system using the Motion Analyzer Cloud. First off, a couple of things for housekeeping. Assuming that you've already registered and logged in, the first thing you need to do is start a new project. Now, one of the things I'm going to be doing is pausing it as it's going through its process because the cloud will take some time. So I don't want to make this video any longer than I have to. So let's start a new project. We'll give our project a name. And then we're going to create the project. Once you've created the project, you'll have this screen come up. You want to go to the project. The next screen will look like this. We need to create a new axis using an application template. You'll have a choice of a rotary type axis, a linear axis with a mechanism, just a linear axis. There's also these defined application templates for a center driven winder and a press roll. These are custom templates. In future releases of this software, they will be adding more application templates. For our application, we're going to use the linear axis with a mechanism. This will put you into the motion profile editor. The first screen that will pop up is your starting points. If you're doing horizontal, you just leave your degrees, your inclination to 0. If you're vertical, then you put 90, or if you're inclined, you put in whatever the degrees of incline that you're at. Select the Get Started. So the first thing we want to do is add a trapezoidal index. We're going to do a simple 2-inch move in 1 second. We'll put a little bit of S-curve in there just to smooth out the profile. We put in a coefficient of friction, which will be listed off the belt manufacturer's spec sheets. We'll put in 0.01. You put in your payload. In this case, we'll just move a 5-pound load. Next thing you want to do is add a dwell. We'll leave it at ½ second. We'll add another trapezoidal index. This will be the reverse move, so we'll put in 2 inches in 1 second. Also 40% S-curve. 0.01 coefficient of friction. This is the return move, so we won't have any payload to move back. Because this is the return, you have to invert the profile. And then let's add a final dwell. So this is what your profile should look like. If you want to clean it up a bit, just turn off these extra viewpoints and you'll see our position versus our velocity. If you're happy with this profile, make sure you save it and continue to the axis. This will bring you back to this screen. Next, we want to add a mechanism. So we're just select the Define Custom. You can do belt drives, rack and pinions, chain sprockets, and lead screws. Since we're doing a belt, we'll define it as a belt. We'll give our belt system a name. On this page, we're going to enter in the belt data. Let's go with a 3-inch diameter pulley. On your drive side, on your driven side will also be a 3-inch diameter pulley. Hit the little calculator button here, which is your inertia calculator. We will make this a hollow type cylinder. We'll make the material aluminum. Your diameter, let's just change our units to inches. The outside diameter is the 3-inch that we already defined. We'll make it a 1-inch wide pulley. And the inside diameter, we'll put a 1-inch shaft. The inertia is then, mass inertia is all calculated here. We'll hit the save button, scroll down, hit the applied, and there's the calculated inertia of that particular pulley. Let's just simply copy and paste over to the driven end. We'll give a number of rollers, element of 1. Let's make the belt 1 pound, and we'll put any type of tooling, we'll put that as a 2 pound mass. Make sure you save your work. Continue to the axis. Next, we'll define your input voltage, which we will make at 460 volts, 3-phase power. Okay. At this point in time, being a belt system, typically you would have to put a gearbox on there. So we'll add a gearbox partner. Well, these are the partners of Rockwell, so Stober, Shimpo, Wittenstein, Apex Dynamics, Harmonic Drives, and you can also select other manufacturers. We'll just select a Wittenstein gearbox. At this point, we really don't know what type of gearbox we want, so we'll just browse for the families. On this screen, you have the different types of Wittenstein gearboxes. We're going to select the inline value for our project. Save this selection to our axis. Once we're back at the main screen here, we're going to search for the solutions. I'll warn you, this may take a little while. Next, you will have a solutions list. We can filter the products and the families. So in this particular application, we want to be using the Kinetics 5500 with a VPL low inertia motor. 132 solutions. So let's select the 132. This will minimize the views just to those particular gearboxes. So we can analyze the profile matching, look at relative pricing, average current, force or torque utilization, inertia ratio, peak current, and thermal capacities. So what we're kind of looking for is thermal capacity. We want to try to keep that down under 50% if possible. The inertia ratio, try to keep it under 10 to 1. You can see we're not even 0.5 to 1. So here we're using a 40 to 1 gearbox with one of our smallest VPL motors and one of our smallest drives. We can also view the torque curve and have a quick view of what's going on. You can see that the green line represents the RMS torque values of the motor, and the red line is the peak. So our motion profiles that we've entered are pretty close to the RMS, so this may not be a very good match. If we scroll down, we can pretty much see that we're going into slightly larger motors now and a slightly larger drive. Plus we're only at a 10 to 1 gearbox here, which is a single stage, which will help keep costs down. Inertia ratio is still pretty good. Thermal capacity is under 50%. And if we view the torque curve, you can see that we're well within the operational limits of the drive and motor. So this looks like the best match. So let's select this guy. We can then go into the performance and see how well it's going to perform. And again, you can see that we're 39% of thermal capacity of the motor. This is based on that 40% ambient temperature that's set at the beginning. Continuous torque is at under 50% and peak torque is at 31%. The drive thermal is at 44%, current is at 44%. So this looks like a pretty good match. At this point, we want to set the configuration of the products that have been selected. So let's go to the gearbox first. Hit the select configuration. Once open, we're going to select the gearbox combination that we have there. We will save it back to the axes. Now we want to do the same thing for the motor. These are the various types of motors with combinations. The C is single turn, the 1-2 is no brake, the AS is shaft sealed installed in the factory, the 1-4 is a holding brake. So in this scenario, let's go to page number 3 and let's pick the VPLB 1001M PJ12AA. So this will be absolute positioning and no holding brake. Next, we want to do the same thing for the drive. So you have a 2198-H008 ERS2 and a 2198-H008 ERS. The 2 is SIP safety, whereas the ERS is just hardwire safety. Let's just go with the standard Kinetics 5500 here. Our next step is let's pick the cables to go with this motor and drive. So hit the cable selection tab. Let's change our units to meters. We'll use a 15 meter cable. Let's just use the single cable because that's what this motor will take. It will be flying lead, and you have a choice between a non-flex or a continuous flex cable. Because this is just a horizontal unit, we'll just take a standard cable, non-flex rated. Pick the first one, so it'd be a 2090-CSW M1DF 18AA15. We're going to continue to the project. And let's take a look at the power analysis. Here we're going to check to see if there's any kind of regen going on and whether we need any shunt resistors. So as you can see here, we have the inverter power and we have no regen going on, so we do not need a resistor. You can do an analysis down here to see what's going on, and again, we don't have any regen on this particular axis. From there we can go to the selected products, and this will list your hardware that's required for this project. If you click on the show, we'll show you the cable that we selected. That concludes this session of the video. On the next video I'll be doing, we'll be adding a vertical axis to this. Thank you for watching.